O of a circle has coordinates 4, 7. So that would be 4, 7. So let's say that's about there. And a point A on the circle has coordinates 6, 11. So that would be 6, 11. So that would be, I mean, this is not a great circle. I am not Giotto by any stretch of the imagination. I don't know if he could do that. 4, 7. Find an point A. So that's that. That's at. Okay. So point A has that. 4, 7, 6, 11. AOP is the diameter of the circle. So that's P there. Find an equation of the tangent to the circle at point P. So first, first what we're going to do is we're going to work out what the equation of this line is here. So this line L, or the diameter, should we call it D? Well, that's not very well written. So D, let's start off by working out the gradient. So the gradient will equal, this is y1, this is x1, and that's y2, and that's x2. So it'll be 11 minus 7 over 6 minus 4, which equals 4 over 2, which equals 2. So far we know that D equals y equals 2x plus c. And now to find c, we can put in the easiest ones. So we can put in 7 and 4. So let's make it 7 equals 2 times 4 plus c, which equals 7, 8 plus c, and so c equals minus 1. So that's what this one is. D equals 2x minus 1. Now we could do with knowing how long the actual diameter is. So diameter length, we know, would equal, we'll make a little, if we made a little triangle out of that, so 4 to 6 is 6, 7 to 11 is 4. Sorry, 4 to 6 is 2, 7 to 11 is 4, so it's going to be, so we know that the length of this, or half d, let's make it r even, so we know r equals the square root of 2 squared plus 4 squared. That's from a squared plus b squared equals c squared. So that's 16 plus 4. Put those in the wrong places, square rooted. So r equals root 20. Okay, so we know that r equals root 20, so d equals 2 root 20. So now, in order for us, or we could do something even cleverer. So from 6, 11, we could go down like this. We could go down 8, and we could go along 4. So if we do that, because I've just realised it was a bit hard doing it the other way. So if we go down that, that means we end up with 3 there, and we end up with 2 there, which is actually, so down by 8, yep, and down by 4, so that's 2. So that's 2 over 3. So that's, the P is going to be at 2, 3, and it's on D equals 2x minus 1, or y equals 2x minus 1. So that means we now know that in order to find out the tangent at P, because it goes through like that, oh, that was really bad. Right, the tangent at P goes through like that from there. So that means it's a perpendicular. So that means that y will have to equal the negative reciprocal. And we don't know about c, but to find out about c, we use that, and we say 3 equals minus a half times 2 plus c equals, so 3 equals minus 1 plus c. So c equals, if we add 1 onto both sides, c equals 4. And now we know the answer is y equals minus a half x plus 4. And I feel like I took ages over that, so I'm going to stop now.